Welcome students, today we will solve 11th problem on trusses and we will solve this problem through method of sections. So let us start today's lecture. So we are given one truss over here and we are asked to find forces in members HF, HG and IG of this truss by method of sections. We know whenever we have to solve any problem of trusses through method of sections, then first step is we should identify the types of supports given in the truss. So in this truss we are given two supports. One is pin support at joint A and other is roller support at joint L. We know pin support provides two reactions, one normal to its surface and second along its surface, while roller support provides only one reaction, that is normal to its surface. So let us label these reactions. Let us start with the pin joint first. So we have labeled its normal reaction and we have assumed the direction of this reaction in our direction. And let us label it as RAY, that means reaction at A in Y direction. Let us label other reaction, that is along the surface of pin support, and let us consider the direction of that reaction towards right. We have labeled this reaction as RAX, that is reaction at A in X direction. Now let us label the reaction at roller support, and we know roller support provides only one reaction, that is normal to its surface, and for this reaction we have assumed its direction in upward direction. And let us call this as RLY, that is reaction at L in Y direction. So first step is identify the supports given in the truss and label the reactions provided by those supports. Next step is we have to find the values of these reactions through equations of equilibrium. So let us apply the second step. So now we will find RAY, RAX and RLY through equations of equilibrium. Let us first apply summation Fx is equal to 0. So let us see how many forces are acting in x direction in this particular truss. There is only one force, RAX. That means RAX is equal to 0. Now let us apply the second equation, that is summation Fy equal to 0. Let us see how many forces are acting in y direction in this truss. There are 10 forces. Two forces RAY and RLY are acting in upward direction, so we have to consider these two positive, while other 8 forces are acting in downward direction, so we have to consider these negative. So equation will be RAY plus RLY minus 1 minus 1 minus 1 minus 1 minus 1 and minus 5 minus 5 minus 5 equal to 0. So from here we will get one equation, RAY plus RLY equal to 20. So in this equation we have two unknowns, we cannot solve this equation, so let us call this equation as equation number 1 for time being. Let us apply the third equation, that is summation m equal to 0, and let us take moment about joint A. Now in this truss total we have 11 forces, but these two forces are acting at joint A, so their perpendicular distance from moment center is 0, so we will get rid of these two forces. But for this equation we have to find moment because of other 9 forces in the truss. So let us discuss these forces one by one. Let us first see the moment because of this reaction about joint A. Now this reaction will generate anti-clockwise moment about joint A, and that will be a positive moment. And its magnitude will be RLY into 30, because this is the line of action of RLY and this is the moment center. The distance between these two is 30, so magnitude of its moment about joint A will be RLY into 30. Now let us talk about the next force, that is 1 kilonewton force acting at joint J. Moment because of this force will be clockwise moment, so that will be negative, and its magnitude will be 1 into 25. The next force acting at joint H, which is of 1 kilonewton again, will generate clockwise moment, so that will also be negative, and its magnitude will be 1 into 20. The next force is of 1 kilonewton again acting at joint F. It will also generate clockwise movement, so we have to consider this as negative, and its magnitude will be 1 into 15. Now we have 1 kilonewton force acting at joint D. It is also a clockwise movement, so it will be negative, and its magnitude will be 1 into 10. Next we have a force of 1 kilonewton at joint B. It will also produce clockwise movement, that means negative movement, and its magnitude will be 1 into 5. Then we have a 5 kilonewton force acting at joint G. It will also generate clockwise movement, so we have to consider that negative, and its magnitude will be 5 into 15. Then we have a 5 kilonewton force acting at joint E, and it will also generate clockwise movement, so we have to consider this as negative, and its magnitude will be 5 into 10. Then we have a 5 kilonewton force acting at joint C. It will also generate negative movement, and its magnitude will be 5 into 5. It means final equation will be minus 1 into 5, minus 1 into 10, minus 1 into 15, minus 1 into 20, minus 1 into 25, minus 5 into 5, minus 5 into 10, minus 5 into 15, plus RLY into 30 equal to 0. So from here we will get value of RLY as 7.5 kilonewtons. And we got positive answer. That means the direction which we assumed for RLY is correct. Once we get value of RLY, then we can find value of RAY through equation 1. We will say put value of RLY in equation 1 to get value of RAY. It is equal to 12.5 kilonewton. So this is also positive. That means the direction which we assumed for RAY is correct. So there is no need to reverse that direction. So we have concluded that RAX is 0, RAY is 12.5, and RLY is 7.5. So let us label these values now. So we have removed RAX and we have labeled RAY and RLY. Now in the next step we have to find forces in these three members of the truss: HF, HG and IG. So let us see where are these three forces in this truss. HF member is over here. This is HG member and this is member IG. It means we have to find forces in these three members of the truss. So it means we have to cut the truss from this section, because only then we can satisfy the two conditions. That is, section must cut at the most three members of the truss, and those cut members must include the members of the truss for which we have to find the forces. Now you can see we have to find forces in these three members, so we have to cut these three members to satisfy those two conditions. Now we have divided this truss into two sections. This is left section, this is right section. Now we can choose any of these two sections for the next step in order to find the forces in these three members. So let us consider the right section of this truss because it has less number of forces. So equations will be simple. So we will say equilibrium of right section of the truss. So for that we have to draw free body of this right section of the truss. In order to draw right section of the truss, we have to draw 7 members first. 1, 2, 3, 4, 5, 6, 7. Then we have to represent this reaction at joint L. and we have to represent these two external forces at joints J and H. After that, we have to show these cut members also, HF, HG and IG. So let us draw the free body of the right section. So we have drawn 7 members over here. After that, we will represent these cut members. And we have represented external forces at joint H and J, and we have shown reaction at L also. Now let us represent these 3 cut members. So this is member HF, this is HG, and this is IG. Then in the next step, we will label the direction of the forces in these 3 cut members, and we will label those directions away from the joint. Means we will consider tensile forces in these 3 cut members. So this is member HF. So in this member, we have labeled its force FHF away from the joint, that is tensile force. This is member HG. So we have labeled its force FHG away from the joint, that is tensile force. Then this is member IG, and we have labeled its force FIG away from the joint, that is tensile force. Now after this, we will see, is there any inclined force acting in this free body? Yes, there are 2 inclined forces. Then in the next step, we have to resolve these 2 forces into their components. So let us first resolve this force into its components. So this is the origin of this force. So from this point, we will sketch 2 lines, one in horizontal direction and other in vertical direction. So these 2 lines are representing components of this force. Now let us represent the direction of these 2 components. For that, we have to see the direction of force first. Direction of force is away from the joint. So in these 2 components also, we will assume direction away from the joint. Direction away from the joint. After that, we will find the magnitudes of these 2 components. So for that, first of all, we have to see the angle of this force with any of these 2 components. So let us locate the angle of this force with the horizontal component. Let us call that angle as theta. Now let us find this theta first. You can see this theta is similar to this angle because this is the same line, and to that line we have drawn 2 horizontal lines. It means these angles will be same, that is corresponding angles. Now if we can find this theta from the truss, then we will be able to find this theta as well. So let us find this angle from the truss. This angle in the truss is over here. So we can say in triangle FGL, tan theta is equal to perpendicular upon base. That means 8 upon 15 is equal to tan theta. Or we can say theta is equal to tan inverse 8 by 15 equal to 28.07. So we have found the value of theta. And we are considering angle of this force with this horizontal component. So this will be cos component, other will be sine component. So let us label this as FHF cos 28.07 and this component as FHF sine 28.07. So we have resolved this force into its components. Now in the next step, we have to resolve this inclined force FHG into its components. So this is the origin of this force. So from this origin, we will consider one component along x direction, other component along y direction. The direction of this force is away from the joint. So in this component, we have to assume direction away from the joint. So in this component, we have to assume direction away from the joint. Now let us find the magnitudes of these 2 components. So for that, we have to first find angle of this force with any of these 2 components. So let us locate angle of this force with this component first, and let us call that angle as phi. So let us see where is this phi in the truss. This phi is over here. Now if we will see this triangle HGI, in this triangle this angle is phi, and if we have to find this phi, then we need the values of these sides of the triangle, but we know only this side of the triangle, that is 5 meters. We don't know the length of side HI and HG. So if we want to apply tan phi, then we need perpendicular upon base. Perpendicular we know, that is 5 meters, but base we don't know, that is HI. So first of all we have to find HI. So how we can find HI? Now let us consider these two triangles, FGL, this bigger triangle, FGL. Then consider this smaller triangle, LHI, LHI. So these two triangles, FGL and HIL, these two triangles are similar triangles. So it means now we can say perpendicular upon base of the bigger triangle will be equal to perpendicular upon base of the smaller triangle. So for phi, in order to find phi, we will say use similar triangles LFG and LHI. So we will say perpendicular upon base, that is 8 by 15 for bigger triangle, is equal to perpendicular, that is HI, upon base, that is 10 for smaller triangle. So from here we will get value of HI, that will be equal to 16 by 3. So we got the length of this member, that is HI. Now we will say in triangle GHI, we will say tan phi equal to 5 divided by 16 by 3. So we will say tan phi is equal to 5 divided by 16 by 3. So from here we will get angle phi equal to 43.15. So we have found angle phi. Now we have considered angle of this force with this component, so this will be cos component, other will be sine component. So let us label the magnitudes of these two components now. So we'll call this as FHG cos 43.15 and this will be FHG sine 43.15. Now we are ready with the free body of right section of this truss. Now we will apply equations of equilibrium to find the unknowns. So let us apply the first equation, that is summation fx is equal to 0. So let us see how many forces are acting in this truss along x direction. First one is FHG sine 43.15. Second is FHF cos 28.07 and FIG. So we have three forces acting along x direction, but these three are acting in negative direction. So equation will be minus FHF cos 28.07 minus FHG sine 43.15 minus FIG equal to 0. So in this equation we have three unknowns, so we cannot solve this equation. So let us call this equation as equation 1 for time being. Then we will apply the second equation of equilibrium, that is summation Fy equal to 0. So let us see how many forces are acting along y direction. First is FHG cos 43.15 acting in downward direction, so we have to consider this as negative. Then FHF sine 28.07 acting in our direction, we have to consider this as positive. Then 1 kilonewton force acting at joint H in downward direction, we have to consider this as negative. Then 1 kilonewton force acting at joint J in downward direction, we have to consider this also negative. Then reaction acting at joint L in upward direction, we have to consider this as positive. So equation will be minus FHG cos 43.15 plus FHF sine 28.07 minus 1 plus 7.5 equal to 0. So from here we will get equation minus FHG cos 43.15 plus FHF sin 28.07 equal to minus 5.5. So in this equation again we have two unknowns. So we cannot solve it. Let us call this equation as equation number 2. Now let us apply the third equation. Now what is that equation? That equation is summation m equal to 0. Now over here we have to observe a very important point. What is that point? We have to judge that at which joint of this truss or this section of the truss we should apply a moments equation so that we should get the value of unknown forces. Now we have to find these three unknown forces FHF, FHG and FIG. Now you can see these two forces FHG and FHF, these two are acting at joint H. So if we will consider moment about joint H, then moment because of these two forces will be 0 because these two are intersecting joint H. So we will get rid of these two unknowns. So in that equation there will be only one unknown, that is FIG. So we can solve that equation easily. So let us consider moment about joint H. So if we will consider moment about joint H, then we will left with only three forces for which we have to find the moment about joint H. Those are FIG 1 kilonewton and reaction 7.5. So let us discuss the moment because of these three forces about joint H. FIG will generate clockwise movement, so that will be negative, and its magnitude will be FIG into HI. HI we have already found, and the value of HI is equal to 16 by 3. So its magnitude will be FIG into 16 by 3, and that will be a negative moment. Then we have to find moment because of 1 kilonewton force about joint H. Now it will also generate clockwise movement, so we have to consider this also negative. And its magnitude will be 1 into this distance, that is 5 meters. Now let us see moment because of this reaction. This reaction will generate anti-clockwise movement, so we will consider this as positive, and its magnitude will be 7.5 into 10 into 10. So equation will be 7.5 into 10 minus 1 into 5 minus FIG into 16 by 3 equal to 0. So from here we will get value of FIG as 13.12 kilonewtons. We got positive answer for this force. That means this is our tensile force. Now once we get value of FIG, then what we will do, we will put this value in equation 1. And if we will do this, then we will get equation 1 in terms of FHF and FHG. Equation 2 is also in terms of FHG and FHF. So we will get two equations in the end having same unknowns. So in these two equations we have two unknowns, so we can solve these two equations easily. So what we will do, we will put value of FIG in equation 1 and we will solve equation 1 and equation 2, and we will get value of FHF as minus 13.81 kilonewtons. So we got negative sign, so it will be a compressive force. Then we will get value of FHG as minus 1.37 kilonewton. So we got negative sign, so this will also be a compressive force. So we have found the forces in these three members of the truss. So I hope this numerical is clear to you. Thank you very much.